Pick up any drill bit in any hardware store or machine shop and look at the spiral grooves cut into the shaft. Those grooves are called helical flutes, and they were designed by one man in one small shop during the American Civil War. His name was Stephen Morse. He filed a 7-page patent in 1863 for a self-clearing drill bit, and the geometry has never been replaced. Every twist drill made today, whether it costs a few dollars or comes from an industrial supplier, still follows the same fundamental design. The company that grew from that patent armed the United States through 2 world wars, employed thousands in New Bedford, Massachusetts, and then was dismantled by corporate parents, debt, and neglect. Stephen Ambrose Morse was born in 1827 in Holderness, New Hampshire. His family had no industrial pedigree or capital. He attended common schools and then Franklin Academy, and his first trade was not machining, but jewelry and watchmaking, where he learned micro-tolerance precision work. His older brother moved him south to Lowell, Massachusetts, where he learned machining at the Lowell Manufacturing Company. In the 1840s, he moved through major New England shops, worked for locomotive builders, spent time in Elias Howe's workshop, and briefly partnered in Boston. Those years gave him the practical skill that his later inventions would need. By 1860, Morse had settled in East Bridgewater, Massachusetts, and opened his own small shop in 1861. The Civil War had just begun, and government contracts were flooding machine shops that could supply the Springfield Armory. The problem every machinist knew was drilling metal. The standard spade drill was crude and inefficient. It clogged with chips, wandered off-center, overheated, and had to be withdrawn repeatedly to clean the hole. Production was slow, dangerous, and imprecise. Morse set out to fix that. He designed a drill with 2 helical flutes, spiral grooves that acted like an Archimedes screw, pulling chips continuously out of the hole. He added radial relief behind the cutting edges to reduce friction and heat. That allowed a machinist to push the drill straight into the work and keep cutting without constant withdrawal. On April 7, 1863, the U.S. Patent Office granted his patent for the improved drill bit. The point angle that later became standard was refined over time, but the core idea was already there in Morse's original patent. He then invented the Morse taper, which was just as important. As drills generated more torque, square shanks would slip or break. Morse designed a self-holding tapered shank that fit into a matching tapered spindle. The friction of the 2 surfaces locked the tool in place, and a simple drift wedge could remove it afterward. The Morse taper became an international standard and still appears in lathes and drill presses today. It is one of those quiet industrial inventions that shape entire systems while staying invisible to most users. In 1864, Morse partnered with investors and incorporated the Morse Twist Drill and Machine Company in New Bedford, Massachusetts. New Bedford had been a whaling capital, but with whale oil declining, local capital was looking for a new industrial future. Morse gave those investors one. The first factory was small, but within 25 years the company had expanded to 2 full city blocks. It built a pedestrian bridge between buildings on opposite sides of the street, and during Christmas the bridge carried illuminated tree shapes that generations of locals remembered. The company also became part of the town's identity in a more serious way. New Bedford workers did not see it as a distant corporate plant. It was the place where neighbors, cousins, and in-laws earned wages, learned trade discipline, and built enough stability to buy houses nearby. The city's industrial life and the company's growth became intertwined, which made later decline feel like a civic wound rather than a simple business failure. The man and the company soon diverged. Morse left the business in 1868 after a dispute with the board, not because of ill health. He moved to Philadelphia, founded Morse Williams & Company, and ran that business for more than 20 years. He later acquired several other firms and retired in 1891. He died in 1898 and is buried in Philadelphia. The company he left behind did not need him to continue. Under later leadership, Morse Twist Drill broadened far beyond twist drills. It made taps, dies, reamers, end mills, drill chucks, countersinks, gauges, and grinding machines. Its taper gauge sets were deposited with the U.S. Bureau of Standards as national references. The company also bought competitors and patents aggressively, including Rockford Twist Drill, Beach Chuck's patent rights, and other tool firms. By the 1890s and early 1900s, Morse was a central player in American metalworking. That growth reflected the fact that a good twist drill is not just one product, but a family of small geometry decisions. Point geometry, flute depth, relief, and material all determine whether a tool cuts cleanly or burns, whether it clears chips or packs them, and whether a hole stays straight or wanders. Morse turned those variables into a repeatable commercial standard. That is why his name lasted. The design solved a universal problem and did it in a way that could be taught, copied, and trusted. The company embraced high-speed steel early, moving from carbon steel to tungsten and molybdenum alloys that could cut faster without losing hardness. That mattered because the First World War turned tooling into a strategic resource. Morse exported to England, Russia, and Germany and became one of the American companies most capable of meeting wartime demand. High-speed steel did not just improve productivity, it helped keep the war machine supplied with machined parts. The Second World War pushed the company further. The New Bedford plant ran 3 shifts, employing about 1,700 workers and producing cutting tools at several times normal output. Morse drills, reamers, and taps were used in the production of Sherman tanks, B-17 bombers, and Liberty ships. The factory ran around the clock, and the town's economy depended on it. Families worked there across generations. The wages were solid, the union was strong, and the plant anchored the neighborhood. That union was UEE Local 277, part of the United Electrical, Radio, and Machine Workers of America. The union survived the anti-communist purges of the late 1940s and remained independent, militant, and rank-and-file driven. That independence would matter later because Morse's future would be decided not just by technology, but by ownership. In the shop itself, the wartime years also hardened the company's culture around production discipline. Fasteners, drills, and cutting tools had to arrive on time and perform predictably because military supply chains did not forgive missed specifications. The New Bedford workforce learned how to keep machines running under pressure, and that routine made the plant one of the region's most dependable industrial assets during the war. In 1923, Van Norman Machine Company bought most of Morse twist drill and operated it as a separate New Bedford corporation. Later, Universal American absorbed Van Norman and grouped Morse with other industrial brands. In 1966, Gulf and Western acquired Universal American, and Morse became one small piece of a huge conglomerate portfolio that included entertainment, publishing, resorts, and zinc mines. Gulf and Western did not buy Morse to make drill bits. They bought the cash flow. That was the problem. New Bedford had a profitable plant, but the profits were being drained to finance acquisitions elsewhere. The factory itself was not modernized. Across the 1970s, Japanese and German competitors were building new climate-controlled CNC plants, while Morse workers used older grinders and equipment that dated to the war years. The buildings leaked, the wiring aged, and the corporate response was not reinvestment, but higher quotas and cost pressure. The contrast between the old plant and the new overseas competition was stark. Morse had once been a model of manufacturing progress, but by the late 20th century, the same buildings that had supported wartime production were now a liability. Management wanted the cash the factory generated, but not the capital expense needed to keep it competitive. That mismatch is one of the quiet reasons so many old industrial companies break down. The asset is profitable in the short run, while the infrastructure behind it slowly decays. In 1982, the union struck when Gulf and Western demanded wage cuts, benefit reductions, and seniority concessions. The union brought in a worker ownership consulting group and exposed how the conglomerate had been disinvesting from a profitable plant. Churches, civic groups, and local leaders rallied behind the workers. The strike was won, and Gulf and Western backed down. 2 years later, the conglomerate announced it would liquidate the plant anyway. The workers and the city fought back harder. The union built a broad coalition, and New Bedford's mayor and city council threatened eminent domain if the company shut the factory. The message was blunt. If Wall Street wanted to strip the plant and leave, the city might seize it instead. Under that pressure, Gulf and Western sold the company. The buyer in 1984 was James Lambert, who acquired Morse cutting tools and related assets through a leveraged buyout. Initially, the sale looked like a rescue. The union cooperated, the state provided a loan, and new customers added business. For a short time, it seemed possible that the plant might survive. But the debt load was crushing. Lambert shifted cash into other ventures, suppliers stopped extending credit, and the plant could not bridge the gap between material costs and incoming payments. In early 1987, Morse filed Chapter 11 bankruptcy. Roughly 350 workers received layoff notices, and the cutting tool division was shut down. The plant was eventually abandoned, then repeatedly vandalized and set on fire. Scavengers stripped wiring from the walls. Fires lit up the New Bedford skyline. For the surrounding neighborhood, the factory had gone from employer to hazard. The bankruptcy was especially painful because the plant still had technical value. Machines and know-how were not the issue. The issue was capital structure and ownership. Morse had been turned into a financial asset rather than a manufacturing enterprise, and the factory could not survive being treated as a balance sheet line item instead of a production system. That is a theme that repeats throughout industrial history. Good engineering cannot save a plant if the money flows in the wrong direction. In the mid-1990s, the city took the property for unpaid taxes. Environmental testing found contamination from petroleum, solvents, and industrial waste that had seeped into the soil and groundwater. CBS Viacom, which had inherited Gulf and Western's liabilities, became responsible for the cleanup. Extraction wells, vapor mitigation, and soil remediation followed. The final closeout did not come until 2018. The site where the modern twist drill was born remains a brownfield lot, though a community garden and redevelopment plans now sit nearby. The Morse name survived the factory. After liquidation, the intellectual property moved through a chain of owners. Greenfield Industries became the brand custodian. Then TDC in China acquired Greenfield in 2009, and in 2024, Walter Surface Technologies bought it from TDC. Morse cutting tools are still sold today, some made in South Carolina, others through TDC's integrated supply chain in China. They are solid mid-tier industrial tools, though not what the name once meant. That survival is partly because the geometry still works. A twist drill does not need a marketing story to be useful. It needs to start straight, clear chips, and keep cutting without burning the part or the tool. Morse's original design solved that problem in a way that was simple enough to scale and durable enough to outlive the company that commercialized it. Few industrial inventions are that clean. The real legacy is the geometry. Morse's helical flutes, radial relief, and self-clearing action still define every twist drill on Earth. His Morse taper is still a standard in machine tools worldwide. The company that grew from his patent is gone, and the factory is gone, but the drill bit design he created during the Civil War is still spinning in machine shops, construction sites, CNC cells, and garages everywhere. That durability mattered because the drill was not just a specialty tool. It was part of the basic vocabulary of making things. Once a shop standardized on Morse geometry, every operator, every machine, and every replacement tool could work from the same expectation of fit and chip clearance. That made procurement easier, training easier, and production more predictable. In industrial life, that kind of standard quietly saves time every day. That is why the bit still feels modern. It was designed around the job, not the fashion of the day, and the job has not gone away. From repair benches to production lines, the same spiral groove still solves the same old problem: how to cut a clean hole and get the chips out before they ruin the work. The company also left behind a deeper lesson about manufacturing systems. It showed that an invention can be both a product and a platform. The twist drill made the company money, but the taper, the gauges, the taps, the reamers, and the later high-speed steel tooling turned Morse into a whole ecosystem of cutting technology. Customers did not just buy a bit. They bought a compatible way of working. That is why the brand endured even after the plant failed. Tool users remember the products that become part of their muscle memory. If a drill cuts true, if a taper seats cleanly, if a tool survives a hard shift, the company name keeps traveling from one generation to the next. Morse's name survived because machinists kept using the logic he designed into the tool. There is also a moral edge to the story. The company that made the modern drill bit helped win wars, train machinists, and fill warehouses across the country, yet it collapsed because ownership treated a productive plant like a financial resource to be harvested. The building burned, the soil had to be remediated, and the city had to live with the after effects. The invention lasted, the institution did not. That is the story of Morse cutting tools. One man's solution to a bottleneck, one company's rise to industrial importance, and one of the few inventions that can honestly be called functionally immortal. The shop is gone, but the spiral grooves are still everywhere.